All right, reverse linked list. Reverse a singly linked list. A linked list can reverse either iteratively or recursively. Could you implement both? And so given this input, we have 1, 2, 3, 4, 5, and the input is just the linked list backwards. So kind of an obvious brute force approach would probably be to store the elements into an array or store the values into an array. So we could iterate over the linked list and then add 1, 2, 3, 4, 5, and then simply call reverse on this array, which would in fact turn to 5, 4, 3, 2, and then 1, and then kind of traverse this array. And as we traverse this array, we could print out the nodes or create the nodes and then assign all of them. But the follow-up that they're looking for is that we would implement it either iteratively or recursively. So the recursive approach would be something like, given this array, if we do start from the head node, or the root, which is basically going to be this node, we're going to do a type of backtracking where we're going to traverse all the way to the end. And then when we hit null, and when either our current node is null or the next node is null, what we want to do is keep track of what our previous values were, and then kind of like traverse back this way with being stuck in the recursive calls. So we would have 5, which would more or less point this way, and then 4, yeah, this would probably be easier. Just build it out. So we have, as the recursion or the call stack collapses on itself, we'll kind of just have the nodes reverse as they go back, and then 2, 3, 4, 5, and then finally eventually we'll have the entire list printed out this way. And so the time complexity and space complexity will be the same. The time it'll take to do all the backtracking will be linear, and then the space complexity for the recursive calls will be linear also. So we can go ahead and implement that. We'll minimize this to make it easier to see. And so we can check if there's no head or there's no head.next. We will just return head because it'll be null, and then we can grab the previous values, which would be recursive call to reverse list of head.next, and then we'll say head.next will be null, and then head.next will be head, and then we can return previous. Choked up in the last part. I think these are backwards. This is null, and this is head. Yeah. And so that's the recursive implementation. Now the iterative solution is, in my opinion, a little easier to understand. So given the same linked list, all we're going to do is iterate over the linked list, and all we have to keep track of is the previous value, which we'll initialize to null, because that'll be the end of our linked list. And then we'll also, when we start iterating, we'll keep track of a next node. So basically null will start here in the beginning, and then we'll say that this is our, we'll say previous, let's do previous p, which would be null, and then we have p, which would just be starting off as null and empty space. and then we'll have basically our head, which is what we're going to start off with, and then we'll have our next node. And so at each iteration, we're basically going to, so yeah, previous, head, h, let's just start off at the root, and then we'll say next, which will be n, which will be our next node. And so we have our head here, which is where we start off in our next node. And what we basically want to do is while we're iterating over, we're going to change the pointers. So, excuse me, our head will point to null. It'll no longer be pointing to 2. It'll be pointing to our previous pointer. Then we will move our head pointer and our next pointer over, and then move our previous pointer over here, and then do the same thing. This no longer points to 3. Ooh, this is getting... Alright, so this no longer points to 3. Our 2 now points to the previous, and then our previous pointer gets moved over to here, and then our head and our next pointers both get moved over, and then we do the same thing. 3 no longer points to 4, and now we just keep doing this process of moving everything over until eventually we have our head and our next. We would finish the list, and then previous would get updated, and then head would be here. And now 5 would simply point to our previous. Our next is null, head would become null, and our previous pointer would be 5. So we would just return this. And this would be the iterative approach. So our time complexity will be O of n, and the space will actually be O of 1. So it'll be constant because we're just using 2 pointers instead of like backtracking like we did up here. Okay, so let's just implement it. So previous will start off as null, and then we'll say while head exists, and then we'll say next will be head.next. Head.next will point to our previous pointer, kind of like what we said here, down here, as we slowly change the pointers, and then our previous will become our head, and then our head will become our next, and then ultimately we'll just return our previous, which would be the new root of our node. Very cool. So those are the 2